Hello everyone and welcome. In this module we're going to talk about the topic of inflation in the context of engineering economic analysis. The objectives of this module are as follows. First, we're going to talk about the real and actual dollars, what are the difference between them, what are the definitions, and then we're going to incorporate inflation into a cash flow analysis. We'll be able to incorporate the effect of inflation on before tax and after tax calculations and see how does that impact the measures such as net present value and rate of return. And then we'll use spreadsheets to conduct the economic analysis and also incorporate the impact of inflation. So let's start with the meaning and effect of inflation. So far, what we have seen in all the cash flows that we have worked with are all constant value dollars. And that means the dollar values do not change over time, does not inflate. Inflation causes money to lose purchasing power. So purchasing power is really the impact of inflation. And inflation, as you can imagine, makes future dollars less valuable than present dollars. So inflation impacts two quantities, both interest rate and cash flows. And we're going to start by looking at the impact on the interest rate. So let's start by these three definitions. The first one is inflation rate itself. Inflation rate itself, we denote that with this F. And that means annual rate of increase in number of dollars needed to pay for the same amount of goods or services. Essentially a percentage that shows the inflation per year. And in the United States, that is on average between 2 and 3% per year. And then we have real interest rate. We show that with I prime, and that measures the real value of money excluding the effect of inflation. So we're essentially taking out the effect of inflation. You'll see how, and you'll see more details about it. And then we have market interest rate, I. And market interest rate is the interest rate that you know of. The interest rate in general marketplace, when you see interest rates advertised, on banks or on any other advertisement, those interest rates are typically market interest rates that include both the interest rate and the inflation. So for example, if the bank tells you that we're giving you 5% interest rate, that means part of that 5% is going to cover the inflation, and part of it is going to be the real interest that they're going to gain from maybe putting your money in a savings account in that bank. Now the question is, what meaning should be attached to the interest rate I that we typically use in our analyses? The interest rate that we're using is different because if you're dealing with savings accounts and loans, the I, or the interest rate that we use, is the market rate. But in problems that deal with engineering projects where you invest some money and then over time you gain revenue on that investment, and at the end you probably have some salvage values, in those type of problems the interest rate is the real rate. And you know that the real rate is I prime, market rate is I. Just to remind you. Now, in order to clarify these definitions, let's take a look at one example. This one says, suppose a professional golfer wants to invest some recent golf winnings in her hometown bank for 1 year. Okay. Currently, the bank is paying a rate of 5.5% compounded annually. Assume inflation is expected to be 2% per year. Identify I, which is the market rate, F, which is the inflation, and I prime, which is the real rate. Repeat for inflation of 8%. All right. Now, we need to identify these three parameters in this problem. So, the inflation is 2% per year. That's a given. So we know that F is 2%. and the bank is paying us a rate of 5.5% compounded annually. And we know that the rates that bank give us, those rates are market rates because it includes the inflation in there. So I, or the market rate, is 5.5%. Now what we're looking for is the real rate. So if we can solve for I prime, if you remember a few slides back, the relationship between market interest rate, real interest rate, and inflation is in this equation. So we can use that and here solve for I prime, and that's what's happened here. We know the I, we know the F, we're looking for I prime. And you can solve it and you will see that it's 3.4% per year. So what does that mean? The market rate that the bank offers us is 5.5%, but the real rate is 3.4%. I bet you know what that means, because the real rate is less than market rate because it does not include the inflation. This market rate that the bank gives us covers the inflation as well. So when you extract the inflation out of this, when you exclude it, you'll end up with 3.4% interest per year. And that is the actual gain of putting your money in that account. Now, if we repeat this for the inflation rate of 8%, what happens? So imagine the market rate is still 5.5%, but the inflation rate is 8% now. What happens? You probably can guess that we'll end up with a real rate of negative. And that's exactly what happens. When you have the inflation of 8%, your real rate will end up being negative 2.3%. Essentially, if you put your money in that account, given that inflation is 8%, you're going to lose 2.3% of your money after 1 year. So that's the real rate. So 1 does not include inflation, and that is the real rate, and 1 includes the inflation, and that is the market rate. So we're going to talk about 2 new definitions, and those are actual dollars and real dollars, which are actually very related to the concepts or definitions of real rate and market rate.